number 9, we need to factor these polynomials over z, which means over the integers. So we don't want any fractions and we don't want any decimals on our factors. We just want to factor over the integers. This first one is a quadratic and it has 3 terms on it. So it would be nice if this coefficient was 1. It's not 1, but we can set up a polynomial quadratic that does have a coefficient of 1 there that's related to that. And the way you do that is multiply by whatever that number is. Multiply all of this by 8. So if I do that, I have 8 times 8x squared plus 8 times 22x plus 8 times 15. I've just distributed the 8 through. Now I have changed the polynomial when I do this, so I have to remember in my last step, somewhere down here, the last step, make sure I divide by 8 to compensate for multiplying by 8 right here. But what that allows me to do is take this 8 times x times x, x squared is x times x, and I can rearrange these factors so that I have an 8x times 8x, which means I have 8x squared. Rearrange these factors and multiply the 8 times the x to get 8x, and that's multiplied by 22. Notice how I have the same group there and there. That's what I want. And then 8 times 15 is 90, I believe. Probably not right. Oh, 120. How about that? 120. Now that I have the same group here and here, I can substitute a letter for that. So I'm going to use u for 8x. U is equal to 8x. So I can call this u squared plus 22 times u plus 120. And then I can factor this using the strategies from Algebra 1. It's going to factor into binomials, if it factors. And I need factors of 120. That means they're multiplied together, but they need to add to give a positive 22. So if this is a plus, that means that these signs here and here, or here and here, are alike, and this tells you what they are. They're both positive. So a plus and a plus. So if I go through the factors of 120, 1 times 120 is not going to work. 2 times 60, 3 times 40, 4 times 30, 5 times something, 24, geez, can't think, 6 times 20. So it's not working yet. I'm looking for factors. These are all factors, and I want them to add together to give 22, so I'm not there yet. So 7 and, maybe the ones that we started with, the 8 times 15. 8 times 15 gives you 120. It also gives you a sum of 22 if you add them together. So 8 here and 15, which means we have u plus 8 and u plus 15. So these are the factors of this polynomial that we came up with a coefficient of 1. Now we need to take this back to x's. So we need to take wherever we have a u, we need to go back and put 8x in there. So we're going to have 8x plus 8 times 8x for that u right there plus 15. And then remember, we have to divide by 8. And before we divide by 8, we need to look at these two and see if there are common factors in either one of them. So I can see that these two terms in this factor have a common factor of 8. So I'm going to factor that out. 8x divided by 8 is x. 8 divided by 8 is 1. These terms in this factor do not have anything in common, so they just stay like that. Now I can divide by 8, and these 8's will cancel out, and the factors that are left are the factors of the original problem up here. So this 8x squared plus 22x plus 15 is equal to x plus 1 times 8x plus 15. Now on B, you have an x to the 4th power minus 13x squared plus 36. So it kind of has a quadratic form, but it's not squares. And we do have a coefficient of 1 right here. So let's think about how we could rewrite this x to the 4th as something squared. Well, if I took x squared and then squared it, then I would have x to the fourth. Okay, so we would multiply these powers together. So this expression is the same as that. And then minus 13 times x squared. Now I'm grouping that together so you can see that I have the same group here and here. And then plus 36. So unlike the other problem, I didn't have to multiply this through by anything to make it work. I can go ahead and pick a letter for my x squared there and there. So I'm going to let u be x squared, which means I can call this u squared minus 13 times u plus 36. And then I can factor this easy quadratic. I need factors of 36. The signs are going to be alike, and they're both going to be negative this time, so a negative and a negative. And then when I add those together, I have to get 13. So we think of factors of 36. 1 times 36, 2 times 18, 3 times 12, 4 times 9, and the 4 times 9 should work. If I have a negative 4 and a negative 9, I multiply them together, I get 36. If I add them together, I get, that should be negative 13 right there. So that makes this u minus 4 and u minus 9. Now I'm ready to take these factors and substitute the x squared for the u. So I have x squared minus 4 times x squared minus 9. All right, so those are binomial factors of this x to the fourth original problem. We want to factor it completely. If you notice that this factor is the difference of squares, because this is a perfect square and so is that. So if you look at that factoring pattern, that's going to factor into x plus 2 times x minus 2. This is one of the identities that we talked about today. And then the same thing here, that's a perfect square, and they're subtracted. So that's going to factor into x plus 3 times x minus 3. So this is my final answer for the factors of that fourth power. We have one more factoring to do, and this one fits our sum of cubes. So your identity says that if you have a perfect cube plus a perfect cube, then it's going to factor into a binomial, which means two terms, and then a trinomial, which means 3 terms. And to get the first one, you're just going to take the cube root, which is x, keep this sign, and take the cube root of 1, which is still 1. And then to build your trinomial over here, we're going to use this information. We're going to square the x and get x squared. If you multiply those together, that's 1x, and we want to change the sign to negative 1x. And then we want to square the 1, so plus 1. And you have that identity written down on your note card, so you should be able to do that.